Okay, hi everyone. My name is Sharon Jebito. I believe we have never met over the sessions. Maybe during the first call, just there. I think onboarding call is maybe when we met. I've never taken the Web3 track, but for this, the learning phase, I'll be part of the mentors who will be taking you through the learning phase. So today is the first session for the learning phase, and I'll be the one taking you today, but we have other Web3 mentors. So I'll just share my screen. Thank you. Okay, so in case anyone has something to say, you can just speak up and I'll stop. Then I hear what you have to say. And then again, I know during the preface, we covered the wallets and transactions, and also today's class is about that. But since we were just covering the preface with all the other tracks like the UI UX track, the Web 2, and the project management track. So every track was doing the same thing, like the content you are using was the same ones we were using for the other tracks. But right now we want to focus on the Web3 track just for you guys. So we might repeat some things that we had covered just for the sake of how how the learning phase will be. So our session today will be on wallets and transactions, and I'll just begin. So on wallets, so a wallet is used to describe few things in Ethereum. So I believe, let's say when the mentor was taking you through the preface, I believe he told you that let's say whatever we'll be talking about mostly will be in regards to Ethereum blockchain, even if we know that maybe we can still build or work with smart contracts on networks like Solana, but for this curriculum, we'll just be mostly focused on Ethereum blockchain. That's why, let's say, this wallets is, let's say, touching on Ethereum. So, of course, they can be wallets even for, let's say, Bitcoin, but now this is much focused on Ethereum. So a wallet is used to describe few things in Ethereum. At a high level, a wallet is a software application that serves as the primary user interface to Ethereum. So in just before I go far, I think you guys, let's say, did a demo of MetaMask. So when we are talking about these wallets, you can just have MetaMask in mind. Just let's say now when we are saying our wallet is a software application, you can just think of MetaMask the way it is, and maybe it will be easier to understand this. So our wallet is a software application that serves as the primary user interface to Ethereum. The wallet controls access to users' money, managing keys and addresses, tracking the balance, and creating and signing transactions. So just talking about, let's say, the MetaMask wallet, MetaMask will allow users to have access. No, now MetaMask will be able to maybe display the balance that the user has. It will also help the user manage the keys and the addresses that they have for, let's say, the different accounts that they have created on MetaMask. And then, of course, tracking the balances and creating or signing transactions. So let's say signing transactions, it could be maybe let's say for a case of maybe minting an NFT, before you mint it, you'll have to sign or confirm that transaction. So with the help of a wallet like MetaMask, you'll be able to create or sign transactions. In addition to some Ethereum wallets, okay, in addition to maybe what we have said, the Ethereum wallets can also interact with contracts such as the ERC20 tokens. And more narrowly, from a programmer's perspective, the word wallet refers to the system used to store and manage the user's keys. So these users' keys are now, let's say, the public key and the private key. So there is a common misconception about Ethereum, and that is Ethereum wallets can contain Ether or tokens. In fact, very strictly speaking, the wallet holds only keys. Okay, so according to this misconception, they're saying that, let's say people believe that now these Ethereum wallets only contain, let's
Sorry,
say,
Sharon.
yeah,
Can you please zoom in on your presentation?
okay.
Thanks.
Is it okay now?
Yes, it is. Thanks.
Okay, I was talking about the common misconception, which is that, let's say it's believed that the wallets only contain, let's say, the various tokens that the user has and maybe Ether. But here they're saying the real sense, the wallet holds the keys. Up there, it's in that the wallet enables the user to track the balance they have. Now the balance could be in Ether or the other tokens. But what the wallet actually does is to hold the keys. So the Ether or other tokens are recorded on the Ethereum blockchain. So it's recorded on the Ethereum blockchain, and then through the wallet, the user can just track the balance they have. And then users control the tokens on the network by signing transactions with the keys in their wallets. So in their wallets, they have the private keys and the public key. And let's say you visit a site that you have to connect your MetaMask wallet, maybe in order to make a transaction, you have to connect your wallet. And in that process of, let's say, confirming the transaction, that's the idea of signing that transaction. So for it to be possible, it will your keys are the ones that will enable you to sign those transactions. In a sense, an Ethereum wallet is a keychain, that is a device that is used to hold keys. Ethereum wallets contain keys, not Ether or tokens. So wallets are like keychains containing pairs of private and public keys, and users sign transactions with private keys, thereby proving they own the Ether, and the Ether is stored on the Ethereum blockchain. So I can say for this, just a second. Okay, so I can say that for this part of the wallet, important to note the, let's say, what the wallet does, and of course putting the MetaMask wallet into mind, that what, okay, putting MetaMask wallet as an example of Ethereum wallet and what it enables the user to do. Of course, we have talked about tracking the balances, managing the keys and the addresses, and creating or signing transactions, as well as maybe creating accounts, and each account will have maybe multiple addresses. So that's what a user can maybe do with a wallet, or what a wallet can enable a user to have maybe control of, apart from maybe knowing what a wallet actually does, is noting the idea of the wallet holding the keys. Now, I believe when in the previous, like the preface, we talked about the idea of the private keys being private, and the user has to keep them privately. And these private keys has its like key pairs, the private key and the public key. The public key can be shared, which it could be the public address that someone you can send to someone so that they can send you maybe some ether. But for your private key, you have to keep it privately. And now the private key will play a role when maybe you're confirming a transaction. Yeah, confirming a transaction or signing transactions. So those are things to put note of when looking into the wallets. So the types of wallets. Okay, there are two primary types of wallets, distinguished by whether the keys they contain are related to each other or not. So the thing that there are two primary types of wallets, and the keys contained, either if they relate to each other or not, will determine the type of wallet. So the first type is non-deterministic wallet, which each key is independently generated from a random number, and then the keys are not related to each other. This type of wallet is also known as J JB or K wallet. Okay, just a bunch of keys. So this is the non-deterministic wallet, and I've been told that it's each key is independently generated from a different random number, and the keys are not related to each other. And then they can also be known as the just a bunch of keys wallet. And then the second type of wallet is the deterministic wallet, where all keys are related to a single master key known as the seed. All the keys in this type of wallet are related to each other and can be generated again if one has the original seed. Oh, there are a number of different key derivation methods used in deterministic wallets. The most commonly used is, okay, the commonly used derivation method uses the tree-like structure as described in hierarchical deterministic wallets. So the second type of wallet is the deterministic wallet, and I think this is the common wallets because we're told that they are derived from a single master key known as the seed. I think maybe this is the seed phrase. So this wallet is derived from a single master key known as the seed, and then all the keys in this deterministic wallet are related to each other and can be generated again if, let's say, if the user has the original seed. So here I also told that, okay, in the first type, the non-deterministic wallet, we were told that it's generated from different random numbers, but for this other one, we're told that it's derived in, let's say, different methods. It's not only one way. So, and they're saying the common, you can just speak up if you have something to say. Okay.
Okay, hello Sharon.
Hello.
Yeah, I'm not really, it seemed like you're just reading a document to us. I'm not flowing, kind of. I don't know if I'm the only one. I don't know if you are being carried along. That's just what I have to say. I don't know.
Okay. Okay, I'm going through this document as I try to explain it. And we'll, like, we started with this part of the wallet, and once maybe I finish this part, if someone has something to ask or if you're not understood something, you can say, then we go back to it. For these, let's say these wallets and transactions, it's much of theory, and I can't just, let's say, have to go through this document. And maybe for the next session, I'll make it more, let's say, in a way that you guys can understand it way better. But today we'll love to maybe go through this way. Okay, if you have something to say, you can just speak up so that I don't check the other side of the chat.
Oh, okay. Hi, Sharon. So I was
Hi.
thinking, this types of wallet, if we could get examples of the deterministic and the non-deterministic.
Okay. We are still to cover it in much detail, and through
Oh, okay,
that,
okay,
yeah.
all right, okay, okay.
So for this, let's say this class, it might be a much theory, so apologies for that, but I'll try to explain it way better. So just finishing with the deterministic wallet, it's commonly used. Okay, we are talking about the derivation method. It uses the tree-like structure, and okay. Oh, so so far we have covered, let's say, the introduction to wallets and just the introduction to the types of wallets, but we'll still look at each of the types of wallets, let's say, independently. So in case someone, let's say, has a question, before we go forward, you can ask. Okay, if there is no question, can just continue. So the non-deterministic or random wallets. So in the first Ethereum wallet, which was produced for the Ethereum pre-sale, each wallet file stored a single randomly generated private key. So such wallets are being replaced with deterministic wallets because these old style wallets are in many ways inferior. So I can say this, I can't give an example of non-deterministic wallet, but it's not mentioned here. But I can say that the deterministic wallet example is like MetaMask, and the first time you create, or let's say when you're setting up your MetaMask wallet on your browser. So of course you already have my MetaMask, so it will be a bit odd to do the demo on the first setup. But on the first setup, one of course has to add the MetaMask extension to their browser. And then once they have set up, when you go to the extension and just click on MetaMask, the first thing you'll get is, I think, creating an account. And when you create an account, you'll get a seed phrase, which you'll have to, I think, confirm so that your MetaMask account can be set up with now the account you have created. So that the seed phrase you get when you're just not even launching, but creating your first account on MetaMask is now, you remember the deterministic key comes with the seed, which is now that seed phrase. And let's say if I was to, let's say, maybe uninstall MetaMask extension from my browser and then set it up again, I'll have to go and look for where I placed my seed phrase for this MetaMask given account. And once now I enter that seed phrase is when MetaMask can now launch my account, the one that exists here. So, okay, when I'll be talking about deterministic account, I'll try to reference back to MetaMask, but what I was trying to say is, just as I talk about the non-deterministic wallet, you're seeing already they are saying this is the first wallet that was used by Ethereum, but currently it's being replaced by the deterministic wallets. So the deterministic wallet is now like what MetaMask does, but I'll try and look for an example of this non-deterministic wallet, then we will have maybe a comparison to it. So just moving on with the non-deterministic or random wallet, we have just said it's the first Ethereum wallet, and each wallet file, each wallet file is stored, each wallet file stored a single randomly generated private key, and then such wallets are being replaced. That part of each file stored a single randomly generated private key. So when we're seeing the comparison between this non-deterministic wallet with the deterministic wallet up there, there is that part which we say that the keys do not match each other, but yeah, the keys are not related to each other, but just, trying maybe to make this understandable when, or the reason why I'm saying MetaMask is an example of a deterministic wallet. So the keys on MetaMask are related to each other. They are pairs. Like the public key is, because it's not this alike with the private key, but they are related to each other. But now for this non-deterministic wallet, the keys are not related to each other. And we are being told that the file the file stores a randomly generated private key. And they're saying that, and just maybe explaining it, it is considered a good practice to avoid Ethereum address reuse as part of maximizing your privacy while using Ethereum to, okay. So this example they are giving, I think it's only narrows down to non-deterministic keys, because for let's say the way it is at the moment with the deterministic wallet, let's say MetaMask, you can use your Ethereum wallet as much as possible. But with this one, they're saying it's a good practice to avoid using your Ethereum wallet address, reusing it just to minimize privacy. And maybe this could be maybe the case that this private key was single, unlike the way at the moment you have a private key and also you have the address, which could be the public key. Also saying that you can go further and use a new address for each transaction, although this can get expensive if you deal with a lot of tokens. To follow this practice, a deterministic wallet will need to regularly increase its list of keys, which means you will need to make regular backups. And if you ever lose your data before you have managed to back up your wallet, you will lose access to your funds and smart contracts. The type of non-deterministic wallets are the hardest to deal with because they create a new wallet file for every new address in just a type just in time manner. So I think, let's say, putting a basis, let's say, on MetaMask wallet, it doesn't make sense for this non-deterministic wallet, because for a case of MetaMask, you don't have to maybe do that regular backups of your keys, because once you have your seed phrase, whenever, let's say you have your seed phrase and I've written it down somewhere, or you know where you have stored it, whenever, let's say, you want to log into MetaMask, let's say in a new device, or maybe you had changed something like an operating system of your computer, you'll just have to enter your seed phrase and you'll get all your, let's say, the addresses that were within that account. But maybe the only issue that can come up is when you forget your seed phrase, but there won't be that idea of a list of new keys being generated regularly, needing you to make backups also regularly. The thing that is important is your seed phrase, and of course you have to keep it well, and also make sure that you have written it down somewhere, because once, let's say, you refresh that page, you might not get it again, and if you forget your seed phrase, it is really hard to, maybe there is no place that says retrieve or forgot seed phrase. That might just go like that. But just viewing it with this non-deterministic wallet, I find the non-deterministic wallet is a bit, I can say, odd. And just as they said, this is the first Ethereum wallet that came. So we can just see that maybe comparing it with the deterministic wallet, it could be an improvement of non-deterministic wallets, or something. If you're to pick between deterministic and non-deterministic, a deterministic wallet could be a go-to, because at least you have the keys which are related to each other, and also the thing that you'll have much concern about is your seed phrase, and you won't have new seeds being generated regularly. Okay, moving to the deterministic or the seeded wallets. There are wallets that contain private keys that are all derived from a single master key or seed. The seed is a randomly generated number that is combined with other data, such as an index number or chain code, to derive any number of private keys. So just, okay, this would have been maybe good to compare notes with when we covered the deterministic wallets on the other, let's say, the preface, because I think that was a bit more understandable. But the reason why this is much theoretical is just to get an extra understanding of it in just a theoretical perspective. But you can, of course, still go back to the slides that we used on the preface. I think week 2, or yeah, I believe it was week 2. So if you remember well, we were saying that for this deterministic key, the part of it, not really the, okay, the private key, part of it is derived from the public key. So for deterministic key, we put into consideration the seed phrase, and this seed phrase will now generate the private key and also the public keys. And this public key and the private key will, let's say, be independent for a given account. So let me just open MetaMask. So here I Okay, I have two accounts. So for this account, you can see that this is now the address of this account or this wallet. Now this the wallet is this entire MetaMask. And then with this MetaMask, you can create as much accounts as you want. But now this address acts as the public key, but just within here, just here, yeah, we have the private key that now this is still that address or the public key for this account, and it's public key because this is what I can send to someone if maybe they want to we make a transaction or so. And but the private key is here. I just don't want to open because this is the account I normally use. So you find that I love to enter my MetaMask password so that after I've confirmed it, the private key will be shown. But now this public key is linked to the private key that is here. Or I can just open with this other one. So the other, let's say the address of the account one was, I think it had a 3 somewhere, but for this one, it's not like the other one. So let me just open the private key for this one. So you're seeing this is the public key. This is what you can send to someone, but this is the private key that it is related with this one. Now, when we are going through this explanation here, they are trying to explain to us how this is generated, but they're still related. And maybe this one, you can maybe paste this address somewhere if you want maybe to send some tokens to this given address. But let's say if I was to confirm a transaction related to this address, it's this private key that would make it possible for that transaction to be verified or so. But we'll get to use independently the private keys, and yeah, mostly the private key when we'll be writing the smart contracts. So just coming back here, it was this part, the second paragraph, we were told that the seed is randomly generated number that is combined with other data, such as index number or chain code. Okay, to derive any number of private keys. Okay, in a deterministic wallet, the seed is sufficient to recover all derived keys, and there is a single backup at creation time is sufficient to secure all funds and smart contracts in that wallet. Okay, the seed is also sufficient for wallet export or import, allowing for easy migration of all keys between different wallet implementations. So this seed is, at times you'll see some some words that are about, I'm not sure if it's 12, and those are put in words, but just the way they have explained that this seed is randomly generated number. So I think they are put in words so that, let's say for a case of MetaMask, they are put in words so that, let's say someone can maybe write them down, then come and use to recover, let's say their wallet or their accounts, or just as they say, the keys that were linked to this wallet. And they're saying that there is a single backup at creation, and it is sufficient to recover all funds or smart contracts that were on this given wallet. And also this seed enables the import, or I think this might not show, but when, let's say I would not have entered the seed of this MetaMask, I would at first launch, I would be shown an option to, let's say, import, or not really, I think mostly it's import or create. So with the help of the seed phrase, you can import if you had an already existing wallet and just enter your seed phrase. And in case you didn't have a wallet, you can just create a new one. Okay, so these designs makes the security of the seed phrase utmost important, as only the seed is needed to gain access to the entire wallet. Okay, on the other hand, being able to focus on security efforts on a single piece of data can be seen as an advantage. So the single piece of data they're referring here is the seed phrase. And if you remember with the non-deterministic wallet, you'd have the keys being generated more than once, like they were talking about it being generated regularly. But for this one, it's just that initial seed that was generated for you when you're creating the account that you'll always be using. So I'm not sure if there are any questions in regards to that. Okay. So the hierarchy, the pronunciation is somehow hard. So the hierarchical deterministic wallets, and seeing that deterministic wallets were developed to make it easy to derive many keys from a single seed. Currently, the most advanced form of deterministic wallet is the HD wallet, defined by Bitcoin's PIB32 standard. The HD wallet contains keys derived in tree structure, such that parent key can derive sequence of child keys, each of which can derive sequence of grandchild keys. So with this HD wallet, there trying to explain. You remember up there they had mentioned that there are several methods of generating the keys for the deterministic wallets. And on the last part, yeah, they mentioned okay, on the last part, they mentioned an example of a derivation method, which was the tree-like structure, which they say that it's used for HD wallets, like now the PIB32, which we are just seeing here on the HD deterministic wallets. So with this, let's say this tree structure derivation method, they are saying that the parent key can derive sequence of child keys, and each of the child keys can derive a sequence of grandchild keys. So this diagram is trying to explain this tree structure derivation method. So now we have the seed, and then think when they were talking about the deterministic wallets, they say that the seed is derived from this. They had mentioned the master key. Okay, just on the first line, saying that the wallets contain private keys that are all derived from a single master key or seed. So here on this diagram, now this seed, so it's weird because up there they say the seed or the master key. So saying that we have the seed, then generates the master key, and then with this master key can have the child keys, and then which derives a sequence of grandchild keys. So this is how the keys are generated for HD wallets, like the PIB32 for the Bitcoin standard. So this is how the but key derivation happens for this case of PIB32 standard. Okay. You're moving to the advantages of the HD wallet, and okay, the HD wallet offers some key advantages over the simpler deterministic wallets. So here we are just seeing, of course, all of them are under deterministic wallets, but they are comparing the HD deterministic wallet, like the BIB32 standard of Bitcoin, over the other deterministic wallets. So I think that the tree structure can be used to express additional organization meaning, such as when a specific branch of sub keys is used to receive incoming payments, and a different branch is used to receive change from outgoing payments. Okay, so just these, when we're talking about these advantages of HD wallet, you can just put in mind this diagram, and when they are saying the one branch can be receiving maybe the incoming payment, and then this one is maybe receiving or maybe sending the outgoing. So when they are talking about the branches, you can view it as maybe these different child keys also, just to try and understand this HD wallet, or as they explain the advantages of them. So with that, they're saying with the tree structure, it can be used to express the different organizations. Like, you can put it in an organization's perspective, and they're saying that a specific branch of subkeys, so one branch of the subkeys is used to receive incoming payments, and then another branch is used to receive change from outgoing payments. And then branches of keys can be used for corporate setting, allocating branches to different departments, subsidiaries, and specific functions. So they're saying, maybe looking at, let's say, the child keys. So they're saying, in an organizational perspective, we can have maybe this specific child key is for a given department, and then within that department, there could be now these grandchild keys are allocated to different areas in this given department. Maybe it's a department of accounting, and then within accounting, there are different things that happen, or where payments can be made or received. And then maybe that's the department of accounting, and then this could be a department of maybe finance, and then this could be maybe education, and then this is another department. So in each department, each branch is allocated to different organization staff within that given department. So they are saying, if these HD wallets can be good for an organizational structure, in that each branch is given to a different department within this given organization. So let's say payments linked to this department are well structured, that they'll happen in this given key, the other one in the other key. So just putting or comparing it with an organization's perspective. Hope that makes sense. And then for the second advantage, they are saying that the HD wallets, okay, just the second advantage of the HD wallets is that the users can create a sequence of public keys without having access to corresponding private keys. So this allows the HD wallets to be used in an insecure server, or watch only, or receive only capacity, where the wallet doesn't have the private key that can spend the funds. So with this HD wallet, they're saying that the the user can only maybe be given access to the public key, but not the private key. So with this, whenever, let's say, the user visits maybe an insecure, let's say an insecure site or server, they can always, let's say, maybe just get to look into the site or do the watch only, receive only, have those watch only or receive only capacity, but they won't be able to spend the funds that are within their wallet because they don't have access to the private key. So those are the advantages of the HD deterministic wallets. So the one that they are now maybe taking advantage of how the tree structure works, or how the tree structure generates the key, and then they put it in a perspective of an organization so that the keys are maybe allocated to different organization, and then that specific key will still have different branches that the different departments within that organization can be allocated to. And then the other perspective is the idea of the user having creating the public keys, and then they can only let's say, if they were to receive some, let's say, Bitcoin or some tokens, they'll be able to receive only, but they are not able to maybe send or get to spend the tokens, not tokens or maybe the Bitcoin in their wallet, because they don't have access to the private key, making the wallet more secure for the user's sake. So those are the advantages of the HD wallets. Okay. So unless someone has a question, if there is none, just continue. So the next part is on the seeds and the mnemonic codes, which are under the PIB 39 standard. So there are many ways to encode a private key for secure backup and retrieval. So currently preferred method is using the sequence of words. Okay, I'm sorry with the mix up, because just for this perspective of maybe the wallets and the transaction, we could still have the just trying to put some relatable stuff maybe on either Bitcoin or Ethereum, because right now we have seen like the HD wallet was talking about the BIB32, which is a, let's say, a Bitcoin standard on wallets. And right now we are talking about the seeds and the mnemonic phrases or the codes, and saying again BIB39, which is still a Bitcoin standard. So just don't get confused. It's just that for this understanding of what we are covering, we might have to bring in use cases maybe on the Bitcoin end or those that we have on Ethereum. So just on this, saying that, wow. Okay. saying that there are many ways to encode a private key for secure backup and retrieval, and the currently preferred method is using sequence of words that, when taken together in a correct order, you can uniquely recreate the private key. This is sometimes known as the mnemonic phrase, and the approach has been standardized by BIB39. So this mnemonic phrase, or the seed phrase, are those words I was talking about that could be around 12, and does not only apply to MetaMask. Even some sites that generate for you their own wallet within, let's say, their application, and then you're given these mnemonic or seed phrases, and then those seed phrases you'll have to maybe write them down, because it's not always advisable to save them, maybe let's say on an email or somewhere online, so you can decide to write them down. And whenever you're trying to, let's say, sign in to that given site, you'll have to enter the words on that, the sequence of words on that mnemonic phrase in a given particular order, so that you'll be able to sign in. So maybe in Web3, maybe you have heard of sites that are used for technical writing. Let's say a site like, I don't, okay, I've seen some sites, and I'm just using an example of a site like Medium, but it's now on Web3. So whenever you want to go and check your articles on that site, or maybe write some articles, you'll have to always enter the mnemonic phrase, which is a sequence of words. It could be 12 words, and you have to put them in that given order. And this mnemonic phrase is still the ones that are being used on, let's say, MetaMask. And as I was saying earlier on, if you want to, let's say, set up your MetaMask on a different, let's say, computer or phone, you'll still have to enter the mnemonic phrase, so that your private key and or the account can be imported or just set up on that given, let's say, computer you are setting up on. So they're saying that this mnemonic phrase is now standardized by BIB39. And then continue. Today, many Ethereum wallets, as well as wallets for other cryptocurrencies, use this standard, and it can import and export seeds for backup and recovery using interoper. Wow. This is hard to pronounce. So what's the word?
It's interoperable.
Okay, thank you. Interoperable. Wow, I still missed it. Okay, they're saying that this standard is used for the Ethereum wallets and those of other cryptocurrencies. And with it, you're able to import and export the keys for backup and recovery using now these mnemonics. I don't want to say the word. So just continuing. To see why this approachable, okay, to see why this approach has become popular, let's look at an example of a seed of a deterministic wallet in hex. Okay, this is, I think this is like hexadecimal. So this is a seed, yeah, a seed of a deterministic wallet, and this one is not in that mnemonic phrase order. Like it's not in the words in a given sequence, but for this one it's in an hexadecimal. And wow, so you see, even those, let's say the 12 words that are independent, even some words can be cat, dog, just a random 12 words. So if, let's say, those words are, let's say, put in a, am I forgetting? Okay, in a given hashing, yeah, in a given hashing algorithm that is used by these seed phrases, it can turn those 12 words into such an hexadecimal seed. So you might find this has its own related, the 12-word mnemonic phrase, but here they're just giving an example of a seed, and then again they are saying that a seed for a deterministic wallet from, yeah, just okay. I'm even trying to explain, and it's here. So they are saying this seed, this is the seed of the deterministic wallet, and then the 12-word mnemonic phrase is these words here. This wolf, Joyce, proud, gown. So let's say if this mnemonic phrase is turned into a seed phrase, which is in hexadecimal, it will be in this format, but its format in a 12-word mnemonic phrase is this way. I'm not sure if it makes sense. So it can be a seed or it can be the 12-word mnemonic phrase. And now, let's say for that case of, let's say MetaMask, when, let's assume I didn't have this account and I want to bring it, and my 12-word mnemonic phrase is this one. So when I just set up MetaMask here, I'll be taken to a page that needs me to enter this mnemonic phrase the way it is. So if I try to interchange maybe wolf with maybe proud, it won't work, but I'll have to put it in the order that they want. But if someone had saved it in, let's say the seed, this one, the hexadecimal way, they'll just enter this way. But most sites require someone to enter this 12-word mnemonic phrase, and they'll be able now to retrieve the account, or import it elsewhere, or export the seeds. So these are the words that I was saying that one has to write them down somewhere, so that whenever they're trying to maybe log into, for example, MetaMask, they'll put them down. Not really logging in on a regular basis, because if it's already set up, you'll only be putting your password. But if you are, let's say, trying to add MetaMask to maybe a new device, or if you add an installed MetaMask on this, let's say this current device, that's when you'll be required to put this seed phrase or the 12-word mnemonic phrase. Okay, moving to the wallet's best practices. In case anyone has a question, just stop me. So the wallet best practices. So as cryptocurrency wallet technology, okay, has not really has. So as this cryptocurrency wallets technology matures, the common in industry standards have emerged to make the wallets broadly, the word is back. I think it's interop. Wow.
It's terrible.
Okay, thank you. So it has made it broadly, wow, that word, and then easy to use, secure, and flexible. So even when we were talking about, let's say, comparing the deterministic and the non-deterministic, we were being told the non-deterministic were a bit, inconvenient, but as this wallet technology advances, it becomes more easy for users to use, more secure, and more flexible. In the ease to use, maybe it could be how the user experience is, and then security is in the sense of the seed phrase, and then also flexibility is the idea that maybe these wallets can be accepted, let's say in match sites. You can find most, let's say, decentralized applications. Most of them accept you to use MetaMask, and you find that most people in the space are using MetaMask. So this is all thanks to the, let's say, the idea that the industry is growing, and also the standards related to the wallets keeps changing in favor of, let's say, the end users. So these wallets, okay, not the wallets, these standards allows wallets to derive keys for multiple different cryptocurrencies, all from a single mnemonic. So assuming a case of this MetaMask, okay, so this is my, let's say, my account, but okay, just entirely for this MetaMask, I only have one 12-word mnemonic phrase, and once I enter it, I'm able to, you're seeing there is of course, there is that Mumbai, and then of course there are, okay, I had uninstalled it and then installed it, but I've not set up stuff like Matic. But the thing they were trying to say here was that with a single mnemonic phrase, we can have as many cryptocurrencies as possible. Like, for example, the way we have now Ethereum, we also have Mumbai, which, even if it's the testnet, it supports Matic, and the other one supports Ether. So with that single mnemonic phrase, you can have as many let's say cryptocurrency. Yeah, cryptocurrencies, you can also have as many accounts as you want, because you can always create an account. You can import an account that was elsewhere, because an account can be independent of the other. If you can remember when we were checking even simply the address, the address of this account one is different from the one for account two. Same with the private keys. So you're able to import an account if you have it elsewhere. So here they're just talking about this standard, making the wallets easy for the users to use, making it more secure, flexible, and also being able to, a user is able to derive keys for multiple different cryptocurrencies. So these deriving keys, I think, comes in that process of creating the different accounts. You can create a new account, and that account will come with a new pair of keys. Now the private key and the public key, just still within that single mnemonic of your wallet. So here they're talking about the common standards for these wallets. Okay, the mnemonic code words based on BIP39 HD wallets. So I know these, let's say these slides, they are not maybe a bit so friendly to you, the way, let's say, we have aligned it, but I'll try to edit them so that the readability is a bit friendly before they're handed over to you, because here it could only be like we are touching the common standards, and it could only be as seeing this stand, let's say BIP39 or HD wallets, then moving to this next, because you're seeing stuff like based on is just a repetition, but I'll try to edit them before they come to you. So these standards now are these ones, like BIP39 HD wallets, then BIP32 multipurpose HD wallet structure, then that BIP43 for multi-currency and multi-account wallets, and that BIP44. So these are the different standards for mnemonic code phrases. So these standards might change or become obsolete for future development. But for now, they form a set of interlocking technologies that have become the de facto for wallet standards for most blockchain platforms and their cryptocurrencies. So just they're saying that these standards that I've read out are being used right now for the mnemonic code phrases, like their standards.
Stands for.
Sorry.
You said?
Yes. You're saying something.
Yes, I know what does the BIP stand for, because they are just giving them numbers, BIP 339, 32. What does it stand for? Is it an acronym, like it's a short form for a particular word, or they just name BIP?
Okay, BIP is the Bitcoin improvement proposal. So if you see EIP, it's the Ethereum improvement proposal. Yeah, so this BIP is the Bitcoin improvement proposal. And I was, yeah. So the thing that happens is, let's say everything on the blockchain is taken a lot into consideration. So there is an improvement standards for, let's say, transactions, how transactions work. But now we are looking into the wallets, and now the wallets, there are some, now these standards that are linked to the wallets. So I think the first one was this BIB32, because we even saw it up there when we were talking about the HD wallets. So as time goes by, the guys doing research, let's say on Bitcoin now, because we are talking about these wallets and all these standards come from now Bitcoin. So the guys working or doing research in this line, when as time goes by, they come with new improvements which might change what was existing or make that standard to be no longer used. That's why you're seeing here they're saying they can become obsolete based on the future developments on these given standards. But as we are talking about at the moment, all of these are being used, like they still influence how these mnemonic phrases are generated or the way they work. So that is on the mnemonic phrases and the standards related to them. So a user can export an mnemonic generated in one of these wallets and import it to another wallet, recovering all keys and addresses. So some of the examples of software wallets supporting these standards include Jax, MetaMask, MyCrypto, and my Ether wallet, which here MetaMask is the common one. And I've tried to maybe bring it up a lot of times. And then here they're saying an example of, so these are software wallets that are supported by these standards. And then the hardware wallets, they have given one example, which is the keep key. So the way we have, let's say, explained how these mnemonic phrases are maybe generated and how they influence how maybe the keys are retrieved, works the same way now for these software wallets and the hardware wallets.
Okay, so I have a question.
Okay.
I opened on Trust Wallet. I was given a seed phrase and the account. But during the training, they told us to open on MetaMask. I did, and it gave me another seed phrase and another account. Is it possible for me to reopen my Trust Wallet account with that seed phrase on MetaMask?
I don't think it's possible.
Okay.
Yeah, because MetaMask is independent of the Trust wallet.
Okay. All right. Thank you.
Okay, up to there, we have come to an end of the wallets, and it would have been great if, let's say, if someone has a question, we can maybe go back or still look into it, because the next part will be transactions, which if there is something that maybe you have not understood, we could go back to it instead of going to the transactions. Okay. Is everyone okay?
Okay.
Okay. Okay. For the remaining time of the class, we can just maybe cover introduction to transactions, and then on Thursday can pick from there. Either me or whoever will be coming for the Thursday class. So now on transactions. So transactions are signed messages originated by externally owned accounts. Okay. I'm really bad with theory and reading stuff, but just okay. So transactions are signed messages originated by an externally owned account and transmitted by the Ethereum network and recorded on the Ethereum blockchain. So here, just trying to explain a transaction, which a transaction has to be signed, and a transaction can be originated from an externally owned account, and then it's transmitted through the Ethereum network. And of course, once the transaction is successful, it will be recorded on the Ethereum blockchain. And as I just said earlier on, this is just a recap of the wallets and the transaction class, which was covered over the preface. So another way to look at transactions is that they are the only things that can trigger change or cause a contract to be executed in the Ethereum virtual machine. So transactions now are the ones that impact whatever changes will happen, whatever changes to the state of the Ethereum virtual machine. That might not make sense. So let's say two externally owned accounts make a transaction between each other. If once they make that transaction, of course, the transaction will have to be verified, and once it's verified, it will now impact the state of the Ethereum virtual machine. Same with the smart contract. If we have a smart contract and an externally owned account tries to interact with the contract address, let's say now these transactions, there'll be a transaction that will be happening when trying to execute that smart contract. Let's say a given function of the smart contract, and it will also have some impact on the state of the EVM. So Ethereum is global singleton state machine, and transactions are what make the state machine tick or changing its state. Now, the state of the EVM is changed by transactions. Contracts don't run on their own, and Ethereum doesn't run autonomously. So, like for contracts, maybe, wow, for contracts, of course, the contract has its own address, and then an externally owned address could try maybe interacting with the smart contract, and that will make the smart contract maybe to be executed, a given function of it to be executed. Okay, so the thing they are just trying to justify is for a smart contract to maybe run or get executed, a transaction has to happen. So for a case of a smart contract, let's say maybe one for staking, it's up to maybe someone visiting that site which enables staking, and of course in the back end they have now that smart contract for staking, and that smart contract has a function maybe called stake. And now when the user comes and connects maybe their MetaMask wallet, because the address that the given address, let's assume the Mumbai testnet or maybe the Ethereum wallet, that will now try to interact with that stake, like the staking function of that given smart contract is what will enable to facilitate a transaction or that smart contract to be executed. So here they're just trying to justify that for everything to run on the Ethereum blockchain, there has to be transactions, and transactions could be within externally owned accounts or maybe an externally owned account with a contract account. Maybe we'll finish with this one for today, the structure of a transaction. And a transaction is a serialized binary message that contains the following data. So for every transaction, there are some specific data that transaction must bear. Like now that serialized binary message, it will have this given structure or given fields that each transaction must have. Some people might call them the members of a transaction, because when a transaction, let's say, happens, most of those data will be listed out. So one of them is the nonce, which is a sequence number and is issued by the originating externally owned account, and it is used to prevent replay. So that's nonce for a transaction. And as let's say, as it has been noted for these nonce, they are putting into, let's say, consideration an externally owned account, and that externally owned account will issue this sequence number, and the nonce will prevent message replay. Like, let's say MetaMask sending the same message that this transaction has been confirmed maybe 3 times. So you'll find it can't happen that way. Once that one is sent, another one, the same one, can't be sent again. And then the next one is the gas price, or at times called the transaction fees, and it's the amount of ether in way that is originating, that the originator is willing to pay for each unit of gas. So this is the gas price. It's not the gas fee. So the gas price, wow. Okay, it's weird because they are saying that the originator is willing to pay for each unit of gas. So, okay, for this one, I'm saying it's a bit weird because I don't think the let's say me, if I'm the one trying to make a transaction, in most sense, I might not be able to determine the gas price. I can only determine maybe the, like the gas limit. But this one, the gas price is determined now by, let's say, the Ethereum network by itself. And of course, the value will still be in Way or Ether. And then the gas limit is the maximum amount of gas the originator is willing to buy for this transaction. Not really buy or willing to pay for this given transaction. So the person or the user trying to make a transaction, they can determine the gas limit, which is the maximum amount of gas they want to spend or pay for this given transaction. And then the recipient is now the Ethereum address of where maybe wherever you're sending the Ether, and then the value of the amounts in Way, of course, whatever you're sending to the recipient, and data. This is the variable binary data, variable length binary data payload. And then there are the V, R, and S, which are the three components of ECDSA. Let me confirm this abbreviation. Okay, that ECDSA is the elliptic curve digital signature algorithm. Okay, they're saying that Ethereum uses the ECDSA to create digital signatures of transactions. And these signatures are used to verify that they are authentic and from the correct sender. And a digital signature can be divided into numbers R and S. And here, I think that we have B, R, and S, which are the components of ACDSA digital signature. I think originating from there. It was not completed. Okay, I think here it should have been the originator, which is now the sender. So, okay, when you're trying to make a transaction, or let's say you're sending, you'll have to click confirm, and that's how you are signing the transaction. And now this algorithm will, I think, generates these V, R, and S. So these, like, as part of this structure of the transaction, this V, R, and S will be listed out, and it's this algorithm that, let's say, generates them. So I don't want to go past here because I'm seeing it's now starting to explain each of these and see members of the transaction one by one. So that's, you can pick on Thursday from there. So in case there are any questions for the remaining 10 minutes, we can take up.